Hello and welcome back. Here's another exercise looking at the Bayes Theorem and calculating what I call these posterior probabilities. So we're sort of calculating probabilities backwards. So once we have a new piece of information, we can revise probabilities. Sounds tedious, right? But let's go through the exercise and hopefully it'll become a little bit more clear just what we mean. Okay, so here we go. We've recently heard a local restaurant has hired a new, highly trained, talented, very well-reviewed new head chef. Upon hearing the news, you go online to a review site and find the current chef has a customer satisfaction rating of 80%. I always like to highlight numbers in these word problems in the event that they might become useful. The new chef has a customer satisfaction rating of 98%. As part of the transition to the new chef, the current chef is tasked with helping the new chef become familiar with the kitchen. At the moment, you learn the current chef is preparing 75% of the meals and the new chef is preparing only 25% of the meals. Okay, so let's get into the first part of the problem. What is the probability of having the new chef prepare your meal? So this is part of why I like to highlight numbers that are within the text, because they can certainly be helpful. The probability that the new chef prepares your meal, well, if they're being split 75 to the current, 75 to the current and 25 to the new, then the probability that it is being prepared by the new chef is 0.25. Similarly, and we can work both of these simultaneously even though that's not part of the question, let's look at the probability that it's done by the current chef, and that would be 0.75. Right? We'll calculate all of the probabilities as we go, just because I suspect they'll become useful towards the end. Part B, what is the probability that if the new chef prepares your meal, that you will be satisfied? So what's the probability of being satisfied given that it was the new chef who prepared my meal? So if I know that it's the new chef who is preparing my meal, what's the probability of being satisfied? Well, that too has been given to us. The new chef has a customer satisfaction rating of 98%. So if I know that the new chef is producing my meal, that 98% chance that I'll be satisfied, compared to what's the probability I'll be satisfied if it's the current chef who's preparing my meal? Well, that's over here, 0.8, or 80% chance that I'll be satisfied if I know it's the current chef who's preparing my meal. Part C. What is the probability of having your meal prepared by the new chef and being satisfied? So now I don't know anything. I don't know who is preparing it, and so I want to calculate, based on the probabilities, the likelihood that it's being produced by the new chef, what's the probability that I'm going to be satisfied? So now this is looking at the intersection. The intersection between it being prepared by the new chef and I'll be satisfied. So here we're going to need to apply the multiplication law. What's the probability that it's produced by the new chef times the probability that I'll be satisfied given that it's produced by the new chef? And so here we've already calculated these values. The probability that it's produced by the new chef, I've already calculated, is 0.25, right? That's coming from up here, part A. And what's the probability that I'll be satisfied given that it's being produced by the new chef? Here I've calculated that already is 0.98, right? This is coming from right over here. So we've got all of our numbers already there. Now let's get out a calculator here. Oops. What is this nonsense? So 0.25 times 0.98. So 0.245. 0.245. So let's squeeze that in for part D. Part C. probability that it's a new chef and I'm satisfied is 0.245. Let's get the probability that it's produced by the current chef and I'm satisfied. So that would be a similar calculation. The probability that it's produced by the current chef intersection, so both of these things happening simultaneously. Again, that's the probability it's produced by the current chef times the probability that I'm satisfied and it's produced by the current chef. We've already obtained those probabilities over here and here. So this is going to then be, oops, I better change my pen. Probability that it's produced by the current chef times probability that I'll be satisfied if it's produced by the current chef. And here we have 0.75 times 0.8, so 0.6. 0.6. So a 60% chance that it's produced by the current chef and I'm satisfied. So these two events happening simultaneously. Okay, without knowing who prepares my meal, what's the probability of being satisfied? Let's call this the probability S, probability that I'm satisfied. So here we need to use our addition law. And we've already calculated all of the probabilities. This is going to be the summation of the probability that it's prepared by the new chef and I'm satisfied, plus the probability that it's prepared by the current chef and I'm satisfied. Now normally the addition law would include an intersection, right? That point where both events occur simultaneously, but in this case it can't be both produced by the current chef and produced by the new chef. So these two events are mutually exclusive. I can't have my meal produced by both of these chefs. So there's no intersection between these two events. So all I need to do now then is carry over these probabilities that we've already calculated right here and right here. So here I have the probability that it's produced by the new chef and I'm satisfied, plus the probability that it's produced by the current chef and I'm satisfied. So this is going to be 0.845. So there's, let's say, an 84.5% chance that I go to this restaurant and I will be satisfied. Okay, that's all that is saying. Probability of satisfaction regardless of who is preparing my meal. Okay, so let's scribble that in. I'm running out of room up here. So my probability of being satisfied is 0.845. Okay, now we get into the Bayesian calculation. So now I eat my meal. I consume my meal. I find it was delicious, so I'm satisfied by this. What is the probability that it was then produced by the new chef? Okay, so now I want to calculate what's the probability that it was produced by the new chef given that I am satisfied. So notice this is kind of backwards from what we've already calculated here. Right? That statement was saying, what's the probability that I'm satisfied if I know that it's being produced by the new chef? Now we're saying, what is the probability that it's produced by the new chef, given that I now know I'm satisfied by this delicious meal? So what we need to calculate here, we've already actually done most of the intermediate calculations. What I need to do here is calculate or determine that probability that it is produced by the new chef and I'm satisfied. So where both of these things happen. It's produced by the new chef and I'm satisfied, divided by the probability that I'm satisfied. So here we can just keep this notation quite general for now, the probability that I'm satisfied. Now we can break this down into its different components, all of these different probabilities that we've calculated. This numerator, this intersection, well, this is obtained using the multiplication law. So this is the probability that it's prepared by the new times the probability that I'm satisfied, given that it's prepared by the new. Now this probability that I'm satisfied, this is the probability that it's prepared by the new chef times the probability that I'm satisfied given that it's produced by the new. So notice those two terms are absolutely the same, plus the probability that is produced by the current and the probability that it's satisfying and produced by the current. Okay, so now we've already got all of our numbers figured out. This numerator, this intersection between being produced by the new chef and I'm satisfied, this is the one that we have calculated. New intersection satisfied. This is this one here. Oops, where's my color? This is this one right here. So this is 0.245 divided by this stuff in the denominator. This is what we calculated right here, right? Probability of being satisfied, 0.845. So that ratio then equals, oopsies, this one here, 0.245 divided by 0.845. And we have, let's round that to 0.29. So given that I'm satisfied with my meal, there's a 29% chance that it was produced by the new highly talented chef. Okay, good. So I hope that that makes sense as to how to do some of these calculations. We did a lot of intermediate steps, but of course all of these, the same answer can be obtained by simply putting in each of these components, right? There's a probability of new can go in here, the probability, the conditional probability that I'm satisfied given that it's new can go in here, and we can substitute in all of the individual components. But all we've done in this exercise is build up the larger components of this calculation. Hopefully makes it a little bit easier to see where those numbers come from. Okay, good. I hope this helps. Thanks for watching.